let's look at oxidation of alcohols. All right. Okay, so you're looking at oxidation oxidation of alcohols. Right, so let's try to understand the meaning of oxidation of alcohols. So oxidation, as we know, that it is just a type of reaction which involves the addition of oxygen, or we can say it is the increase in the oxidation state, or sometimes we can say oxidation is simply the removal of hydrogen, and also sometimes we can say oxidation is just the opposite of reduction. So there are four major definitions of oxidation. We say oxidation is the increase in the oxidation state. Sometimes we say oxidation, it is the removal of hydrogen, or we can say oxidation is just the addition of oxygen, or sometimes we can say oxidation is just the loss of electrons. So all those definitions just define the term oxidation. All right, so when you're talking about oxidation of alcohols, in this rationale we are simply referring to the removal of a hydrogen from an alcohol molecule. So in this specific topic, we are referring to removal of a hydrogen from an alcohol molecule. So that is what we are referring to as oxidation. So think in this way, we are trying to convert from alcohol. When you remove one hydrogen from an alcohol, you remain with what is known as an aldehyde. Then when this aldehyde undergoes another oxidation, we'll have what is known as a carboxylic acid. So this is what is happening. So in each and every step, we are simply removing hydrogen. Okay, so we are just removing hydrogen until you form this carboxylic acid. So this is what we mean when we are dealing with oxidation. So now let's understand what we need to talk about in this session. So we have what are known as oxidizing agent. So when you're talking about oxidizing agent, these are just substances that are able to facilitate the process of reduction. So oxidizing reagent we are saying that they are able to facilitate the process of reduction. And we have two classes of oxidizing agent. We have what are known as strong oxidizing agent and also weak oxidizing agent. So for strong, I'll say this side, I'll say strong oxidizing agent. So strong oxidizing agent. Then I'll demarcate here, I'll say weak oxidizing agent. So some of the strong oxidizing agent we can have this molecule. Okay, we can have this one, which is just ozone. We can have this one, which is just potassium dichromate, potassium manganate. Or we can have potassium dichromate, which is written like that. Or we can have sulfuric acid. And also sodium dichromate. So all these are strong oxidizing agent. But for weak oxidizing agent, we have substances like PCC, which is also known as the full name for PCC. It is the pyrimidine chlorochromate. That is PCC, pyrimidine chlorochromate. Then we can also have DMSO. DMSO, the chemical formula, it is CH3, then close the bracket SO, like that. So DMSO, it is known as dimethyl sulfoxide. Dimethyl sulfoxide is the one which is abbreviated as DMSO. Then we can also have something like this, which is just ethyl nitrate, Et3N. Okay, so these are weak oxidizing agent. All right, now let's look at what happens when you have a strong oxidizing agent and a weak oxidizing agent. All right, so here I will say strong oxidizing agent then this side I'll say weak oxidizing agent. So for strong oxidizing agent, when you have a primary alcohol, strong oxidizing agent are able to convert it direct into they're able to convert it up to a carboxylic acid. So they can convert a primary alcohol to a carboxylic acid, but when you have a secondary alcohol, for secondary alcohols, they're able to oxidize them to ketones. Okay, so that is one thing we must understand there. Then on the other side, when you have a primary alcohol, it can be oxidized to an aldehyde. Then a secondary alcohol can be oxidized to a ketone. So one thing we must understand here, just to help us remember, is that for secondary alcohols, whether it is a weak oxidizing agent or a strong, it converts it into a ketone. Now let's look at some examples on how you can deal with these questions on oxidation and oxidation of alcohols. So you can be given a compound like this. Then they'll ask us to write the product, and they might give us the oxidizing agent like that. So it is now our duty for us to say whether this oxidizing agent they have given us, whether it is a strong oxidizing agent or a weak oxidizing agent. So as we mentioned earlier, potassium manganate, which is the one we've been given here, it is actually a strong oxidizing agent. And because it is a strong oxidizing agent, it is going to convert a primary alcohol to a carboxylic acid and a secondary alcohol to a ketone. Okay, so since it is it's a strong, to convert a primary alcohol to a carboxylic acid. Let me just use the functional group like that. Then to also convert a secondary alcohol to a ketone. So just use this. So this is what will happen. So now let's write the product. So we know that this alcohol here, it is bonded to two carbons, so it is a secondary alcohol. Because it's a secondary alcohol, it will be converted to a ketone. So we'll simply have a ketone there like that. Then for this one, we can see that it is just this alcohol is just bonded to one carbon, so it's a primary alcohol. So this primary alcohol will be converted to a carboxylic acid. So we should have a carboxylic acid there like that. So this is our product. Okay, so this is how we can write our product. Then let's look at another example. I'll erase this. Let's say we have been given then they've given us the oxidizing agent PCC, which is a pyridinium chlorochromate. So what we need to understand there is this a strong oxidizing agent or a weak? So it's a weak oxidizing agent. Because it's a weak oxidizing agent, it will convert a primary alcohol to an aldehyde, then a secondary alcohol to a ketone. So you can see that this alcohol there, it is bonded to two carbons. Okay, this alcohol at this point, it has this carbon rather, it is bonded to two other carbons. So that alcohol is a secondary alcohol. So this secondary alcohol will be converted to a ketone. Then we have a primary alcohol. This primary alcohol, because this is a weak oxidizing agent, it will be converted to an aldehyde. Okay, so we'll have an aldehyde at this point. So we have our aldehyde like that. So this is our product. Let's just look at another one. Let's say we have this. So then the reagent we have this. Okay, let me just okay, so when we have this, you know that this is actually a strong oxidizing agent. So this is a strong oxidizing agent. So because it's a strong oxidizing agent, it will convert primary alcohols to carboxylic acid, then secondary alcohols to ketones. So we can see that alcohol there, it is a secondary alcohol. Okay, you can see that is a secondary alcohol there. Then this alcohol, it is simply a primary alcohol. So we are going to have a product of this kind. So this primary alcohol here will be converted to a carboxylic acid. Okay, so we'll have a carboxylic acid at this point. Then to convert this secondary alcohol to a ketone, so we should have a ketone at that point. So secondary alcohols will be converted to a ketone. So basically, this is what we need to understand about oxidation of alcohols. Thank you for watching, and don't forget to subscribe. So we have materials for A levels and also for secondary. You can subscribe to the app, Meticulous Study Hub app and website, where you find all these data, tutorial videos, and also study materials. To reach out, you can just contact this line or WhatsApp it. Then you can also email us using this email. Then don't forget to like, share, and also subscribe. Have a great day.